Thank you, thank you. Can anyone hear me, even from the back row? All right, thank you, thank you. Welcome, hello everyone, hope you are having a good day, hope you are enjoying Open Slava. I know we have right before the lunch, but I promise I will make it quick. So, welcome to my presentation. Today I would like to talk about how our company transformed from simple batch processing to real-time streaming processing, and the challenges and the specific we have to endure to come to our finish line. Well, so I would like to introduce myself first. I apologize for the scuffed photo, but my name is Petr Kolar. I work at seznam.cz as a senior programmer. That's my official position at the company. But for the past 10 years, I've been dealing with the big data processing, from the past 10 years, I worked from the MapReduce and then with Apache, Spark, and after that, currently we are working Apache Flink, and that's what I will talk about today, mostly. So I introduce myself, and then I would like to introduce my company where I worked. We are called Seznam.cz. Mostly someone would say we are a technological company. It's not that case, more likely anymore, because I think 10 years ago we started to shift from technological company to several medias like Seznam Zprávy, Televize Seznam, and Seznam Podcast. But mainly we also have other products like Mappy.com, emails, and other stuff. Also, we have web engine, emails, maps, but also we have also a platform for advertisers, which we called S-Click, and you can imagine it, or it's very similar to Google Ads advertisement platform. And myself, I work for advertisement division, which is dealing with very big data, as you can imagine. Well, we are mostly serving 1 billion messages per day, and we have to process it save it like big data, serve it to HBase and other databases. On today's menu, I would like to I'm sorry, I'm very nervous, but I would like to introduce what we did in the past, and then I would like to shift my focus to present, what we are doing now, and then I would like to talk about future a little bit. So from the past, I think it's like 10 years ago, we used something called Apache Hadoop with processing 1 terabyte per day, stored as JSON on a Hadoop file system. There was no schema, no nothing. It was a pure JSON. And then it was processed by MapReduce, then Apache Spark, and incremental and daily runs, all orchestrated by Crontab or Azkaban or Airflow, saved to Hive and HBase. And this setup was more complex, more costly, but deterministic and really fault tolerant. But this is basically how it looked in the past. But with the advent of real-time processing and data analysis and the demand for the real-time data, we have to shift our focus to more real-time processing. So there is a big time skip, like I think it's like 10 years. And currently we are using for Apache Flink for real-time processing. So now I would like to talk our current setup. What we have right now, we are processing 3 terabytes per day with all serialized in protobuf 3. Also, we are using messaging system, Kafka, but also we are using S3 object storage. Or processed by Apache Flink. There is no daily run, or it's just increment. It's just a stream. All orchestrated by Kubernetes with the help of Flink Kubernetes operator. We are syncing the processed data. We are all saving to Kafka or S3, and we are now, as a bonus, we are now using centralized schema registry. This schema registry allows us to easily link two events together and then save it to like Kafka or S3. Before that, we have to use shapeless for linking to for linking to events. It was a big mess, and there was no schema evolution whatsoever. The maintenance was really impactful. So this is our current setup. Yeah, this is very high level. So there are like on the left that there are events that come to Apache Kafka. Then we are processing with Apache Flink, and then we are saving again to Kafka, and then it could be saved to S3, or we are processing it again with Apache Flink. So with the shift from the batch Apache vlastně MapReduce or Apache Spark, there is something we lost on the way. Right before that, we had the luxury to with the bounded input data. So you had really, you could say you had like incremental runs that you run every 5 minutes or 30 minutes, or then you have to run it every like once per day to correct the previous data. But here in Apache Flink, you don't have such a thing. There is all of this is unbound data. There is no beginning. There is no end. Everything is streamed. The time is endless, as they say, as the poet would say. So how do you deal with that? Well, there is something that's called watermarks. It's a mechanism in Flink to measure progress in event time. There are basically what watermark tells you that after that, the event time before the watermark, watermark tells you that events that come after that there will, I'm sorry, there will be no events that with the timestamp there is less or equal to the watermark. And this actually allows us to work with the aggregated data and to process the data. But it's not that simple. There could be like events that could arrive late due to various issues, mainly due to infrastructure issues, or at our company we have maintenance downtimes where we have to deal with that. So there is that. So and when we started to use Flink, we actually started to use something called windows. From our perspective, it made sense because before that, with the batch stream, we had like finite data, and the windows really describes that windows when you can do your computation or aggregation. So with the windows, this splits into chunks with some of the time boundaries, and you can apply all those aggregations however you want. There are different types of windows like tumbling, sliding, session window, or global window. I remember that we started to use tumbling window and sliding window for the events. Also, this works like with event time, which we are using. You can also use processing time for those aggregation, but this creates a whole another mess, and I would like to not recommend it. So with that, how do you deal with the late data that comes from the window, that comes to the window? Well, you can use something that's called allowed lateness in the window, which just allows you to process the data that comes late, and it's really straightforward, flexible, but there is a price for that. The window isn't released immediately from the memory, so you cannot really use it for large states. Or you cannot like allow the lateness for the infinite time, if you know what I mean. But for extremely late data, you could also use something called side output that is not included in the window, and you can actually take it and use it for further processing. Or you could, after that, we really had issues with lost data and that, and I remember that we used to do something called restreaming and replays, and but it was really like not really something that we do. But what we also discovered that there is something low level, that for low level joins we could also use coprocess function or keyed process function that actually do not use the window state, and you can process all the data that even after they come late. There is an example of a Windows function that we used. Like you can see, we are using tumbling event time window with the custom trigger, and also we have allowed lateness of some gap, allowed lateness, and also we have side output that we can use. And this is example of the keyed process function that we actually start to use. As you can see, on the left side, there is class definition. I can save my events to various value state and list state, and then process it further as it comes. So on the right side, I can have different functions for processing elements, for clicks or conversions. So this is how we. So I gently touched the topic of restreaming that we are trying to solve at our company, and here in the advertising division. There is the issue, like in our division, that sometimes we have to really correct the data. It is really necessary. So how do you really use it? Or how do you really do it? Yeah, you can just run the stream again, right? It's not that really difficult. You can run it from timestamp or Kafka offset or really save point. And mostly this is the painful experience, because you have to set up like new output topic, and then you have to do some maintenance work to correct it to the sync and such. It's not really something I would recommend. And And this only works for events not deleted for Kafka retention policy, so-called young data. So there is sometimes even a use case that we have to do restreaming for the data for like months ago, and this is not really suitable for this, because I think our latency for Kafka is like 14 days or 15 days, if I remember correctly. But what about older data? Well, we can save it. We save our older data or on S3 or still on Hadoop file system. It's not really, or suddenly it's a bounded stream. It's not the bounded, but it's a bounded data. And we can load the data directly from the S3 to Kafka. For that, we have another tool. We called it Catcher or Duck. Don't ask me why. It's just like that. But there's all another issue with that, because you have to you have to set up even a new input topic for that. And if you are loading new data to new input topics, the order of the events is different. So this creates a really non-deterministic output if you run the restreaming again. Yeah. And also the events in Flink operators are processed in different order. So the output is really different. This can be somehow mitigated by introducing linking window and sort events, e.g. by timestamps. So you can create like, really you can simulate a window, and you can take all the saved data, sort it by timestamp or something, and then save it. Yeah, but this introduces latency in the real-time processing, and we don't really use it. And there is another way. What about using the batch mode execution in a runtime? Well, Apache Flink supports batch mode for bounded data, and even it supports reading directly from S3. But there are main differences between the batch mode and streaming mode in the Apache Flink. In the batch mode, in Apache Flink, the tasks are separated into different execution stages. Something like in Apache Spark. The intermediate results are not saved into states, but are spilled to disk. Stage makes sense. Also, it ignores state backend. This is because the intermediate results are spilled to disk, and data are sorted by timestamp and ignore watermarks, except for the max watermark. What does it mean? That if you have implementation that is dependent on the watermarks, like for example, in the linking window, you can register a timer on the event time, and then it fires on that timer on the watermark. So if there is an event which doesn't belong to window, it could be processed, but again, it can be mitigated in the code. Yeah, in the case of fail recovery, there is a backtracking to intermediate results and really, again, processing it. And also, there are no checkpoints, and checkpoints listeners are disabled. This is actually, if you have sync to Kafka with exactly once, then this doesn't really work in that setup. This is a wrong example, actually. This is the past implementation of our linking window, relying heavily on the timer. As you can see, there is this what it does. I'm sorry. What it does linking two main events into one. But before that, I registered a timer with the event time for I think 30 minutes, and then after 30 minutes that event time has passed, this process function is called on timer, and then there is a linking on the base. But if you would use a batch mode, this would not work because this could also link two events that should not be linked because they are after that window. So with that, I would like to talk briefly about a feature that we are currently building at our company. This is mainly the current, but the setup that we would like to have in the future. As you can see, there is saving data on the S3, which we use another Flink application called Cafex, written in Scala and Apache Flink. Also, we have data availability servers written in Kotlin using micronodes, and for the data insight into Kafka and S3, we are using Trino, current with Apache Iceberg for exploring multiple data sets, and it could also be exploited for some batch processing. But we do also have a schema registry for all schemas, and also we are using Confluent schema registry for that. Thank you. How much infrastructure overhead?
Do you want me to read? Okay, we will start Q&A session. Let's start with the first question. The first question is how much infrastructure overhead comes with setting up and managing Apache Flink, especially set up on Kubernetes? Please, Mr. Kolar.
Well, I don't think there is very much for infrastructural overhead in Kubernetes, because we are using what's called Apache Flink operator officially from the Flink. And what it does, it sets up all the Flink architecture in the Kubernetes and deploys the job on it.
Thank you, Mr. Kolar. Let's move on to the next question. Next question is, when does it make sense to use the Flink and when usually containerized services? Please.
I don't think, what does it mean, containerized services? But when does it make sense?
Maybe someone who raised this question can specify more. Yes, please.
Thanks for the presentation, by the way. So what I mean by that is, like, when does it make sense to use Flink, actual Flink, and when, just normal microservices that process the data? I mean, you cannot use Flink for every single use case when you want to just transform data. I assume that there are cases when it doesn't make sense. Otherwise, we will be all using streaming services. So just, I assume, where is the line?
Yeah, I'm sorry, I don't really have answer for that. Can we talk after that?
Yeah, sure, of
After
course,
this?
of
Sure.
course. Sure.
Thank you.
No problem.
Thank you for the questions. And we move on the last question. When should we consider migrating our batch jobs to Flink streaming? Please.
I guess if you really want real data.
Okay, thanks, Mr. Kolar, gave us the speech. Thank you all of you to be here with us. And I think we are good to wrap up this session. And please remember there will be a panel discussion at 1 p.m. in outdoor tent. Feel free to attend. And now it's time for lunch. You can go outside and turn left, go to the tent to have your lunch. And we will meet at 1 p.m. here. Thank you, everyone.